cannot get by your own body, which cannot be created by your body. So those who are eating meat, they have it via the meat. You should think about having those which are normally not in plants. Additionally, in other form, maybe you eat fish, or you have to think about how to get them on a long term, because you can't create it by your own and you don't get it from meat. So these are the essential fatty acids. We have 20 of them, which are really essential for our life. We need them in different concentrations. Normally we get it by food. Some of them can be created, and those who are vegetarian or vegan have to think about to add those which are not, you don't get it if you don't eat meat. So this is just the long chain. You have these three, CH2, 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 and CH2, and CH2, and then the carboxylic acid, COOH. So very long chain. This one isn't a long one. 1, 2, 3, 4, 5, 6, 7, 8. So C8. Then you have 3, 5, 7, 9, 11, 13, 15, H15, C, and then OOH. OOH. Yeah.
Why do you draw lines with the O of the carboxylic acid?
Sorry?
A single O of the carboxylic acid. Yes, the right. Yeah, this one. Above. Yeah. Why do you draw lines?
Lines. There's a double one. 2. These are the additional electrons on the oxygen. Oxygen has 6 electrons in the outer shell. 1, 2, 3, 4, 5, 6. And we always just talk about the electrons in the outer shell. We don't talk about the sp, 1s1, s2 full orbitals. The first orbital, 1s is full. Then we have 2s1, s2, 2p1, 2p2, 3, 4. Those two and those two in the second main shell are in the outer shell, and those are available for chemical reactions. And that's always the same. Here we have 6, and to symbolize that we have 6, 1, 2, 3, 4, 5, 6, because those have to be shared with the carbon.
So it is important to write them.
Yeah.
But before I used to write exams before.
Yeah, sometimes you don't do that, but if you have to go on some reactions and explaining, then we use them. When we talk about mesomeric border structure, this one can come in. When I just talk about this structure now, only the carboxylic acid structure. I take away the proton, and this is the normal structure. When I take it away, then I have here this structure, and this bonding pair of electrons comes over to this oxygen. Then we have the negative charge here. And when I try to explain the mesomery, then I say this one comes over here, then I have the double bond on that side, and this one comes out, then I have the negative charge on the upper. That is what we, I think, talked about even before, when we talked about carboxylic acids. Then we have to draw all pairs of electrons. And because normally carbon needs 6, now we have 1, 2, 3, 4, 5, 6, 7. That means a negative charge remains. For example, here we need it. So fatty acids, they have a long chain and the carboxylic function for the acid. Normally, we have, for example, C18 and whatever, up to C24 long chain, and at the end, the acidic function. And there are existing more than 20, or I think 20, essential fatty acids. Some of them have a double bond. This one doesn't have, only single bond, only sp3. If we have a double bond, we have to name the place. We say, okay, at the second and on the fourth position, we have a double bond, a diene. Additionally, and those who are having no double bond, we call them saturated acids. When we have a double bond, they are non-saturated. And even here, if you look to food, sometimes you can read high content of non-saturated fatty acids. Where do we find them? Mainly in plants or in fish. In the meat, we have mostly saturated fatty acids. And the thing is, people say the non-saturated are more healthy because they can catch up radicals. Radicals is when you are going out to the sun, you have a high UV in the sun, ultraviolet, which has a high energy content. And the ultraviolet light might crack molecules on your skin. And then it is reparated, so recreated, because you have in the DNA a double helix structure. And if one side is getting damaged, automatically it's repaired looking to the other one. And mostly that works. Then you don't have a problem. It can happen that the repair mechanism doesn't work and you get a different structure on that point. And that could indicate cancer. So the point is, when a bond is cracked via light, you have single electrons, not a pair in the bond. You crack it, then the one part has one electron and the other one, but they are highly reactive. And that's always a problem in your body, highly reactive molecules. We call them radicals. And if you have a non-saturated molecule where a double bond is in, this can react more easy with that radical and catch it so that it doesn't make any problem. So if you have a lot of them, fruit or whatever, then we say that's more healthy. It helps to not get cancer on your skin or in other parts of your body. But that's all theory. Why I'm talking about these fatty acids is because the plant oil, they are looking like that. We have here the glycerine structure, O, and not an alcohol. We have it here now as an ether. We have it CO, and then we have a long rest, 1. O, C, O, and a long rest 2. And even here, O, C, O, and a long rest 3. You might see the structure of the threesome. When you take that away and put an H, then there are 3 functional alcohol, the glycerine. And when we add the fatty acids, this one, here that's the rest. I say rest 1, 2, 3, it can be different. And the C16, C18, C24, totally different, but that structure comes from the acid. Because a carboxylic acid and an alcohol forms an ether, and when we have this structure, this is an ether. Yeah, that's an ether.
It's an ester. It's an ester.
Ester. Sorry, thank you. Ester. I mixed it. Ester. That's an ester. And that is the structure of a plant oil. And we have a lot of different plant oils, from palm oil, from nuts, from rape, from sunflower, whatever, olives. The difference is just the rest, the fatty acid. This structure is always the same. And they have them different aromats, of course, aroma. That's an ester, not an ether. We talked about aldehydes and ketones. We talked about these carboxylic acids. Another derivate, we talk about the derivates here, hydrocarbon derivates. We have the halogen derivates. We have alcohols. We talked about here ester now. We talked about acids, carboxylic acids. Amines is another one. That is a derivative of ammonia. Ammonia is the NH3. The structure of this molecule is a pyramidal, NH3. And the H atoms can be replaced by alkylic rests. One we talk about, for example, about methylamine. A methylamine has one methyl instead of the hydrogen. So we have here CH3. The rest is H and H. H atoms can be replaced by alkylic rests. The alkylic rest is a methyl. Dimethylamine course, that has 2 CH3, CH3, H, that's dimethylamine and trimethylamine. Of course, this one has 3 methyl rests or groups. That's trimethylamine. Amines are weak bases or weak alkyl. Because they can accept the proton. So the ammonia itself, when you add an acid like hydrochloric acid, it forms ammonium chloride, NH4 plus Cl minus. A methylamine can do that as well. So methyl CHNH2 and hydrochloric acid. Then we have the CH3 and H3 plus Cl minus. That's the methylamine hydrochloride. And to show you another, these trimethylamine in a planar structure. This is the same as we already draw it above, the trimethylamine, and it can add a water molecule, and then we have the trimethylamine hydroxide here, CH3, and then a proton is accepted, CH3, CH3. This is positive here on the ammonium and the nitrogen, and OH minus. That's the trimethylamine. Hydroxide. And here you see the alkalic function of that. Each case, the pH level is influenced by this reaction. Okay. So quick run through organics. Just a few spotlights to naming, nomenclature. Because some of them we might need later on. Let's have an end for now. Again, please look to your notes over the Christmas break, but enjoy the time as well. restful Christmas break. Happy New Year for all of you, and I'd like to see you healthy in the new year. Bye-bye.
I'm talking about the chemistry, so we can upload some worksheets or something like that on
Yes,
so we can.
you're quite.
I've already finished that.
You already finished.
That's part.
I'm asking Joseph if he is willing to add more.
If you can, that would be wonderful.
Yeah. I will upload the notes from today, chapter 5 and 6. And I already did the 4th yesterday, so you find the notes. And we will talk about some additional exercises after Christmas, but I will ask Joseph to upload more questions. Thank you very much. Same for you, thank you. Goodbye. Frohe Weihnachten. Ja, guten Rutsch.
Professor, kommen Sie aus